Good day, everyone. I welcome you all to this pre-recorded lecture. For today's topic, we are going to cover a technical overview of magnetic resonance imaging. The objectives for today's lecture are the following. We are going to discuss the following: the types of magnets that are typically used in commercial MRI systems, the fundamental principles of magnetic resonance imaging, the properties of atomic nuclei that allow magnetic resonance, which are the magnetic moments, proton precession in the magnetic field. The magnet room. So the magnet room is this is the major component of MR system in the magnetic room is the magnet itself. So this magnet is large enough to surround the patient with RF antennas or radio frequency antennas that are required for radio wave transmission and reception. What are the magnets used in MRI? So the types of magnet used in MRI are the following: superconducting magnet, resistive magnet, and the permanent magnet. First, let's discuss the superconductive or the cryogenic magnets. So these magnets are also electromagnets, and these are most are solenoid in design. So by far, the commonly used magnet is the superconducting magnet. So this type of magnet is notable in that the magnetic field can be maintained for a very long period of time without requiring a constant source of energy. And this allows the use of extremely strong magnetic fields, which could reach above zero point 0.5 Tesla. And a superconducting magnet is based on the principle that a moving electric charge induces a magnetic field. So further, if the charge moves in a circle, the magnet field is generated along a line orthogonal to the circle. So an easy way to picture this is to curl the fingers of your right hand, then stretch out your thumb as if you're trying to hitch a ride along the side of the road. So imagine that the fingers of your hand represent the direction of the electric current, and your thumb then points in the direction of the magnetic field generated by the current in your fingers. So a superconducting magnet consists of many windings of wire that carry an electric current. So, however, their wire loops are cooled to very low temperatures with liquid helium and liquid nitrogen. And this material or these elements are called cryogens. Cryogens are used to reduce the electric resistance. So the magnetic field generated by this cylinder of wires, as what I've discussed a while ago, runs in the direction along the long axis of the cylinder. So the magnet is generally very long in order to provide a uniform field large enough for imaging. Diba? So to accommodate human for imaging, um, the bore of a superconductive MRI could typically measure 55 to 70 centimeters in diameter. So if you put that, or if you make an electromagnet that that's that is that big, so it really requires um, multiple cylinder of wires. So as you might expect, given the size of the machine, it is likely that the machine requires or required large amount of current also. So needing niya ng um, mataas na current. So therefore, the energy required to maintain this current must be quite great as well. So since the resistance in the wires of the magnet will cause the current to decay over time, So here comes the principle of superconductivity. This is why it's called superconductive magnet. So the principle of superconductivity is discovered in 1911. So this phenomenon is a state in which the resistance in a conductor goes to zero at very low temperatures. So ang resistance daw ng isang electromagnet could reach zero daw if you have a very low temperature. So the temperature is in fact typically very close to absolute zero, so very cold. So therefore, the wires of the magnet are bathed in liquid helium at 4 Kelvin to maintain the superconductive properties of the magnet. So yun siya. So again, superconductive magnets permits higher magnetic field strengths than with resistive magnets. So superconductive magnets are also capable of achieving high field strengths, very high magnetic field strengths. Well, in fact, um, meron na sa research ngayon, ang research ang level or ang field strength in research level is they have made up to 6 Tesla for research. But for clinical MRI, it is only up to 3 Tesla pa lang ang approved. So, yan siya. Now, let's discuss the advantage and major disadvantage of a superconductive magnet. So, one major advantage of the superconductive magnet is high field strength, yun na-discuss ko, which then results in inherently high signal-to-noise ratio or SNR, which could also give you a high-quality image. So, yun siya. Ang major disadvantage lang ng superconductive magnet, of course, the cost, high cost associated with acquisition, setting, and maintenance. So, of course, because you need this type of system needs cryogen. So, hindi mura yung cryogen if you're gonna buy it. Isa pa, let's discuss quench could also occur. So, what is quench? So, quench is the sudden and violent loss of superconductivity. Usually, quench could occur if there is a leak or there is a sudden release of the cryogen. So, mawawala talaga ang superconductivity niyan. So, that is what you call quench. Sudden and violent loss of superconductivity. So, bali dito sa quench, you are deactivating the magnet itself. And if you do quench an MRI system, expect that before mo yan siya mabalik, you will have to spend million or at least a million for the refill of the cryogen pa lang. Okay, now let's move on to the resistive magnets. The resistive magnets are similar to superconducting magnets in a way that they are coils of wire through which a magnetic field is induced. However, ang difference ng dalawa, the wires are not cooled to a superconductive state. So this system does not require cryogens. So therefore, if it doesn't require cryogens, the wires are resistive. So meaning if a current were applied and the power supply disconnected, the power will eventually die out. So kung ang superconductive magnet hindi siya ma-deactivate even off or on ang machine, hindi siya ma-deactivate yung magnet, the only way to deactivate a superconductive magnet is to quench it. ang resistive magnet, if you stop the current supply or the power supply, it would also stop its its magnet, diba? So the major difference, therefore, is one of trade-offs in operating costs. So, ang disadvantage lang talaga ng resistive magnet is it does not require liquefied gases like cryogens, right? So, but it does require, ang gina-require niya is a power supply to keep the magnet at a stable field. So, para maging stable ang kanyang magnetic field, but of course, kailangan stable din ang power. So, as a result of this, as a result of, syempre hindi naman mura ang kuryente. So, as a result of the increase in cost, these magnets are not seen in commercial systems. Hindi mo na to siya masyado makikita. And I'm not sure if it's still present in the Philippines, but I think not. Kasi nga mahal siya. Mahal ang kuryente. And also, these magnets are not seen in commercial systems at field strengths over 0.4 Tesla. Hindi talaga siya mag-exceed ng 0.4 Tesla. It can be turned off when not in use. And of course, since hindi siya nagagamit ng cryogens, it is temperature sensitive. Let's move on to the last type of magnet used in MRI. So the last is the permanent magnets. So the permanent magnets consist of blocks or slabs of naturally occurring ferrous material. So it has a constant field that does not require additional electricity or cooling to low temperatures. So if a superconductive magnet nag-require ng cryogens, the resistive magnet requires constant power supply. Ang permanent magnet does not. Okay? Kasi nga, ang it is composed of, or it consists of blocks or slabs of naturally occurring magnet. Yun. So, ang principle lang ng permanent magnets, if there is an increase of the material, well, of course, the field strength would eventually or will also increase. So, usually, ang field strength lang na makaya ng or ma-provide ng permanent magnets are around 0.06 to 0.35 Tesla na ang kanyang kaya. So, permanent magnets have the advantage that their magnetic field does not extend as far away from the magnet or the fringe field, so take note of the term fringe field, as do the other magnetic field of other types. So, isa din to sa mga advantage daw ng permanent magnet. It cannot provide a fringe field. Okay? Now, if before we discuss the advantage, if ang system hindi nag-require ng cryogen, hindi nag-require ng constant power supply, well, ma-lessen talaga ang maintenance or ang gastos if you are going to use permanent magnets. However, ang disadvantage lang ng permanent magnet are the following. So the disadvantages of using a permanent magnets are its weight and the cost of the magnet. Siyempre, hindi mo lang siya mabibili kung saan-saan. And imagine how massive a magnet kung gaano kalaki ang kailangan niya na magnet, di ba? So, ang cost and the supporting structures. Because of the magnets present, kailangan din ng permanent magnet ang room, dapat stable ang floor. So, kailangan mag-invest ng institution sa flooring nila. Hindi lang yung mumurahing flooring. So, dapat stable talaga ang floor kasi mabigat ito siya na system. And in addition, permanent magnets are susceptible to hysteresis. So, hysteresis is a time-varying change in the field. So, as time goes by, ang magnetic field ng permanent magnet, nagababa yan siya or nag-weaken. So, this is what you call hysteresis. So, permanent magnets are commonly used now for low-cost systems. So, yung ibang hospitals na need talaga ang MRI but could not afford the high-end types, so usually ito ang kanilang gina-acquire. Kasi nga low maintenance siya and it is less expensive than the other types. And also, the cost and the weight of the magnets has precluded their use at higher field strengths. So, take note that regardless of the style or type of magnet used, the BO or the magnetic field must be stable and homogeneous, particularly in the central area of the magnet or also known as the isocenter where imaging takes place. So regardless kung anong type of magnet ang ginagamit sa isang MR system, ang pinaka-importante lang if you are going to have an MRI in an institution is that it the magnetic field should be stable and homogeneous, especially in the center of the magnet. Why? Because, syempre, magnet ang need mo to image, diba? So, paano yun magiging effective or ano mo yun siya magagamit if the magnetic field is not stable and not homogeneous, diba? Pangit din ang ma-acquire mo na image. So, anyway, along the way, we will discuss the importance of a homogeneous magnetic field. But for now, field strength and homogeneity can be increased by reducing the gap between the two magnets. So, ang case ng permanent magnet, ma-increase mo ang strength niya if you decrease the gap between the two. So, usually, ang itsura ng permanent magnet, diba, is this. So, this one, diba? So, here you have two magnets yun siya. So, sa taas and sa baba. So, to increase the strength of this permanent magnet, you have to decrease the gap between the two magnets. So, ang disadvantage din nito, hindi ito good for claustrophobic patients or for patients that are or has phobia in enclosed spaces, diba? Kasi maliit na lang ang kanyang space. Ayan siya. Again, we've mentioned the fringe field. So what is the fringe field? So this is the portion of magnetic field extending away from the confines of the magnet that cannot be used for imaging but can affect nearby equipment or personnel. So itong fringe field, this is the field away, sorry, away from the magnet itself. So if you have a superconducting or resistive magnet system, you will eventually have a fringe field. Itong field, usually at the corners of the room, yan ang ginatawag natin na fringe field. Hindi siya maka-affect sa imaging, but it could affect nearby equipment. Like if you put the oxygen tank here, well, ma-attract pa rin siya, diba? It could still be dangerous. For example, if the personnel only standing at the corner of the room, with a coin in his pocket, so possible pa rin yun siya hilain ng magnetic field. Yung fringe field, yung outside na yun siya, sending away magnetic field. So now let's know the general style of magnets employed. So there are two, so vertical field and horizontal field. So ano ba ang vertical field? When you say vertical field, this one, present ito siya sa permanent MRI systems. So ang direction ng kanyang magnetic field is vertical. So since nandito man ang dalawang magnet, nasa taas at nasa baba, so ang kanyang field is vertical. So ano naman ang horizontal? So in superconducting magnets, for example, since this is a coil of wire, diba? This is a big coil of wire. The magnetic field is horizontal along the long axis of the table or the patient. Again, magnet design, vertical field magnet design uses two magnets, diba? Yung sabi ko, one above and one below. Nuclear magnetism. So the name nuclear itself in NMR. So the NMR device was the first name or term prior to MRI. So the name nuclear in NMR refers to the nucleus of the atom. So certain nuclei have properties that cause them to display magnetic properties. And hydrogen is the most abundant in the human body. Therefore, this is used in clinical MRI. Now let's get to know the hydrogen atom. So the hydrogen atom consists of single proton. The proton has mass, it is positively charged, and spins on its axis. So spinning motion of a positively charged particles will create a magnetic field around the proton. So proton's magnetic field is often termed magnetic moment. Okay. So please don't be confused. I'll just give you a heads up. So when you discuss MRI, usually ang ginatakal natin about the hydrogen is its proton. So why hydrogen? So we know that hydrogen is very abundant in the human body. In fact, it is abundant with a large magnetic moment and it exists in two molecules, water and fats. And hydrogen is considered magnetically active. So basic principles of magnetic resonance. So let's recall that in 1940s, NMR was discovered independently by Felix Bloch and Edward Purcell. Okay, so this next topics I will just make you or we will just familiarize the terms used in MRI para meron tayong idea. Along the way, you will understand and will not be confused of the terms used in the subject. So the principles of NMR is based on the fact that the nuclei of certain elements have magnetic moment. So what is magnetic moment? So magnetic moment is the net strength and orientation of a magnetic field. So this means that if a sample of atoms of an element was placed in a magnetic field, its nuclei would tend to line up with the direction of the field. So each type of nucleus has a quality known as angular momentum. So angular momentum is the angle formed between a precessing object and its imaginary axis. So angular momentum is fundamental to MRI. So if you put a if you put a subject, or let's just say if you put a hydrogen proton in the presence of magnetic field, again, BO is um, magnetic field, ha? Don't be confused. It tends to recess. So, umiikot din daw siya. Okay. Proton spin alignment. Okay. So, anything placed within the magnetic field will become slightly magnetized, so which causes the individual protons to align along the same axis of the magnetic field. Ito siya. When there is no magnetic field present, protons behave this way. So, randomly, ang kanilang mga arrow, or that's what we call vectors, ang kanilang vectors, kahit saan nakapoint. But if there is an external magnetic field applied, they tend to align with the magnetic field. Well, not necessarily na they would align, they will all align with the direction of the magnetic field. Some will still be um, pointing the other way. Okay, so each proton aligns in one of two stable directions. So spin up, which is in the same direction of the magnetic field, or spin down in the opposite direction to the field. So, ito siya. This is an individual proton. So, meron siyang this has dipoles also, north pole and south pole. So, those low energy protons will align with the magnetic field, and those high energy protons will will face the opposite direction of the field. Okay, what is net magnetization? So, net magnetization occurs when more protons align in one direction than in the other. So, it is not necessary na kung saan yung direction ng magnetic field, dun din ang direction ng net magnetization. So, net magnetization is the sum from the word net. It is the sum of the contributions of all magnetic moments of the individual protons. Again, yung sabi ko kanina, does not mean it needs not to be aligned with the direction of the magnetic field. If most of the spins or the protons um, align on the opposite side, then the net magnetization is along this direction. Okay, so net magnetization. Net magnetization can be classified in two components, longitudinal and transverse magnetization. Yeah. So the net magnetization vector can be broken down into two components. The longitudinal magnetization aligned in the direction of the magnetic field, or the MZ, and the transverse magnetization, or MXY, in the plane of orthogonal to the field. Anyway, you just have to familiarize that term. In the long run, we will discuss that. Okay, again, proton spin. So again, um, the concept or the principle of MRI is anchored or based on the fact that each hydrogen proton spin. When you say proton spin, so this diagram below illustrates the difference between spin up and spin down. Well, if you say spin up, directed siya sa direction ng magnetic field. But if it's on the opposite way, it is called spin down. Now, what is precession? Precession is a change in the orientation of the rotation axis of a rotating body. So, nag-aikot siya. Precession. Again. So, precession. So, due to the influence of the magnetic field, the hydrogen nucleus wobbles or precesses like a spinning top as it comes to rest. Ayan. Here is an illustration like that. So, ito siya. This is the hydrogen nucleus. One. This one. This is the magnetic field. And this is the magnetic moment. Yan. Araw ng iyong nucleus. So, iikot ang iyong hydrogen proton, iikot. Now, that's what you call precession. So, the axis of the nucleus forms a path around BO or the magnetic field, which now you will call which is known as the precessional path. So, itong circle sa taas, ito yung path ng pag-ikot ng iyong hydrogen nucleus or hydrogen proton. Now, just like a gyroscope or a spinning top, parang ganyan din ang pag-ikot ng hydrogen proton. Okay. So the speed at which hydrogen precesses depends on the strength of the magnetic field, and this is termed as precessional frequency. If the spinning itself is called precession, the speed naman at which hydrogen precesses is called or termed as the precessional frequency. So the precessional paths of the individual hydrogen nucleus is random or out of phase. So hindi yan siya sabay-sabay umiikot ang hydrogen protons. So it is usually random, or we will also known as out of phase. Now, what is radio frequency? RF or radio frequency is electromagnetic radiation lower in energy than infrared. And the RF used in MRI is in the form of bursts of energy or pulse in the 10 to 200 megahertz range. So brief burst of RF electromagnetic energy delivered to the patient by the RF transmitter. So ang contribution lang ng RF, it just provides or gives off bursts of RF electromagnetic energy. Relaxation. Now, what is relaxation? If there is precession or spin, there is also relaxation. So the term returning to equilibrium is called relaxation. From the term relax, so from the state na excited siya hanggang bumalik siya sa kanyang equilibrium or natural state, that is called relaxation. And it can be thought of as two-step process. The first is a T1 relaxation or longitudinal relaxation, and T2 relaxation or transverse relaxation. So we will also discuss that along the way. Now, let me show you a presentation of how RF pulse knocks out hydrogen proton out of the alignment. Yan. So, diba, if you put a hydrogen proton in the magnetic field, it tends to align with the magnetic field, diba? So now, what happens if there is a 90 RF pulse applied? So yan. So, knocked up ang hydrogen. Ah, and what will happen if na-give off na niya yung RF? So, the hydrogen relaxes and realigns in the magnetic field. Again, in the presence of magnetic field, it tends to align with the magnetic field. The hydrogen proton aligns with the magnetic field. If there is a presence or there is a burst of radio frequency, it will knock up a hydrogen proton, and if it's now delivered, there is no RF. If the RF is now delivered, then the hydrogen slowly relaxes and realigns with the magnetic field. So, yan ang nangyayari. However, remember that hydrogen does not simply pivot back into alignment, but it precesses. So, effect kayo ang hydrogen proton. Nagaikot-ikot yun na siya, hindi lang yan siya steady. Now, let's discuss the Larmor equation. So, the Larmor frequency, it was Sir Joseph Larmor who introduced the Larmor frequency. So, Sir Joseph Larmor is an Irish-born mathematical physicist, and also he is a professor of mathematical physics at Cambridge University. And his famous 1897 equation was to explain the Zeeman splitting of optical spectra due to electron orbital motion. And initially, this equation was not intended for the use or for understanding the NMR. So the Larmor frequency. So the Larmor frequency is the frequency at which the hydrogen precesses. So we have discussed na nagaikot ang hydrogen proton. Now, the rate at which it precesses is called the Larmor frequency, or the frequency of precession. So when a hydrogen proton is near an externally applied magnetic field, or BO, an increase or decrease causes the precessional frequency or resonant frequency also increase or decrease. Ano ang Larmor equation? So this is the Larmor equation. W is equivalent to YBO. So yan lang ang formula ng Larmor. Okay. This is where W is the frequency of precession or the resonant frequency and has the unit of megahertz. Y stands for the gyromagnetic ratio. This is a constant value and has a unit. The gyromagnetic ratio has a constant value for each element or each type of proton. And this has a unit of megahertz per Tesla. The BO is the strength of external magnetic field and has a unit of Tesla. Now, we have discussed that Y is part of the Larmor equation. So Y stands for the gyromagnetic ratio. So the following are the gyromagnetic ratio for different nuclei. So for the hydrogen isotope, it is 42.6. For the other elements, like magnesium, it is 2.6. So different ang gyromagnetic ratio for each different isotope. Okay, we have an example here. So how do we compute the Larmor frequency? So, for example, if we have an MRI capable of having a magnetic strength of 1.5 Tesla, what is the precessional frequency of hydrogen? So we know that the nuclei or the isotope is hydrogen. So this type of isotope or this nuclei has a ferromagnetic ratio of 42.58 or 42.6. So we are going to multiply that with 1.5 Tesla, and now the result or the product will be 63.87 megahertz. So paano naman kung iba yung hinahanap? Like for example, if you're only provided with the um, Larmor frequency or the Larmor frequency, so how, paano mo mako-compute yung magnetic field strength? So here we have a derivation of Larmor equation. Then, if we are going to look for the BO, this is the formula. W divided by Y. So the unit will be Tesla. So when we are going to look for the Y or the gyromagnetic ratio, we will divide W divided by BO. Lang. Okay. That ends my lecture. Thank you everyone for your time, and I hope you've learned something. Bye.